And thanks a lot, Steve. Take it away. Thank you.
Well, hello, I'm Steve Henrichs. I'm the Assistant Pavement Design Engineer. I work at the Materials Lab over in Maplewood, and I'm here to talk about the product of a research project, designing base and sub-base to resist environmental effects. The need statement of this project was that MnDOT has all these pavement design procedures to carry traffic, but not to resist environmental effects. The objective of this was to design a tool that would then calculate the depth of pavement layers to resist the environmental effects. In the beginning, this wasn't stated if it applied just to PCC pavements or asphalt, but in the end, it just applies only to HMA pavements, which for now on, everything I'm talking about is for HMA pavements. I was the technical liaison on the project, but the principal investigator that did all the work was Matt Ullman right over there, and I'm sure he'd want me to mention Neil Lund. Oops. So what are environmental effects? Well, you've already seen this picture on the last presentation, but we got thaw weakening and frost heaving. Thaw weakening is losing strength in the spring from water melting out in the pavement section, and frost heaving is roughness caused by upward movement from the frost. So what causes frost heaving? Well, you need three things for frost heave. You need freezing air temperatures, you need frost susceptible soil, and you need a water source. When you have freezing temperatures at the top of your pavement section, you get a frozen layer, and nothing much is going on in your frozen layer. It's all below freezing, nothing's going on. Down at some depth into your pavement, your water source is staying unfrozen, where it can just stay as water. But in between, in your frost susceptible soil, even though it's below freezing, water inside that microscopic pore structure can remain unfrozen. And this water can rise up through capillary action up to the frozen layer and form into ice lenses. And it's the growth of these ice lenses that actually cause the frost heave. And this process will continue until either you no longer have freezing temperatures or you run out of water. So what are frost susceptible soils? And that's soils that will allow this capillary rise of water. Now, in our triaxial chart, we have three types of material. We have sands, clays, and silts. Sands, they allow so much water to run through that they really aren't frost susceptible. But in clays, they're such an impermeable material that they really aren't a problem either. But silts, they kind of have the in-between sides that have high capillarity and high permeability, which make them highly frost susceptible. So what can you do about this? Well, you can keep water out of your pavement section by having nice ditches and drainage. You can also make your heave more uniform. Or you can replace your frost susceptible soil with frost resistant materials, which brings us to the MnDOT 30-inch, give me a second, the 30-inch frost-free material section, where the entire depth of your pavement, your aggregate base, and your sub-base has to be at least 30 inches deep. And this is based on being approximately 1/2 of your frost depth. Now, but we can do better than this. Frost depth isn't the same across the state. On this map, you can see that on the south, that's about 70 inches deep, and on the north, it's at least 100 inches deep. And frost susceptibility isn't the same for all soils. On this graph, you can see that, you see this graph everywhere too. It's in our manual and it's inside the report. And you can see that on the x-axis that the average heave is on the x-axis and the amount of silt particles are on the y-axis. And you can see where it's almost all silt materials that you have the highest heave. And down on the other side, where you have much less silt material, that you have your lowest heave per amount. So that brings us to the product of our project. We actually got 4 spreadsheets was the result, but we picked one, and I reformatted it, and you put in your location, and along with your silt percentage, it'll give you the amount of material that you need to replace. So the first thing you do is you put in your location information, and I added the very top part in here. You put in your MnDOT road and reference point. It'll give you your latitude and longitude. Or you can, if you know it, you can just put in your latitude and longitude, and it'll find the nearest weather site for you. And this is a weather site that's in a database that's located inside the spreadsheet. And this is NOAA has already recorded what the freezing index for all these different locations are at all through the entire country, although there's probably about 3 dozen Minnesota ones, and at different return intervals. So based on traffic, you'll pick a 90% return interval, and so that's 3,300 at Ada. So with this freezing index, we can then put it into a formula, and that will tell you what the depth of your frost is. Now we have 2 formulas, one for clay and sandy soils. And this came from a study from the Michigan State, I believe. And we kind of lucked out on this because when they had done the report, they asked for our frost data to validate their model. And we have around the entire state, we have a whole bunch of different remote sites that record the temperature of the subgrade so that we can tell what the condition of frost is, so that for spring load restrictions. Now, how much of this material do you need to replace? Well, Matt went and looked at the LTPP database. This is a long-term pavement performance database where I think it's 2,500 sections have been tracked for like 30 years. And he looked specifically at the SP8 sites, which are just the environmental sites. And these are sites that have less than 10,000 easels on them. And from looking at the 8 sites, he was able to draw a correlation, a relationship. On the left, you have the IRI slope. That is the loss in ride per year. And he was able to correlate between that and the percentage of silt in the subgrade and the percentage of frost depth treatment in the soil. Well, this is supposed to be just the environmental effects. So we want that IRI slope to be, it's supposed to be 0. So if you set that formula to 0, you can get the following relationship, which is just your frost depth protection depth against your silt percentage. And that will tell you how much you need to replace in your calculated frost depth. So how do you know how much silt you have? Well, the spreadsheet has an extra little tool for you if you happen not to know. And if you click on the button on there, it'll open up the soil map in Google Earth. This layer actually came from the MnPave flexible program, so it's already been around for a while. So you zoom in on your road and you click on it, and it'll say that you got clay loam is what you have, loam to clay loam. So you go down to the bottom of the program, and you go to the drop down and you put in clay loam, and it'll say just by definition from the triaxial chart that it'll say it's has to be 20 to 50% silt. So me not having any other information, I just picked one from out of there for 35% silt. And so from the top end, it calculated out that 75 inches of frost. From the percentage of silt, it said I need to replace 49% of that. And so the total frost protection depth is, that calculates as, voila, 37 inches. So what's next? What are we going to do with this? Well, we're looking at it. Do the calculations appear correct? To me, they look pretty good. Does it need any adjustments? Well, I guess we'll have to find out. Can projects be designed with the results? Well, we just aren't really going to know until we compare it with some projects. Maybe it says it needs to replace 70 inches up by War Road. I mean, are we really going to do that? Or maybe it's going to be thin down someplace else. We'll just have to find out. So can we make it a standard? I guess that is what I would like to do, but we just aren't going to know until we've had it around for a while and let it cook and find out. So that was my last slide. Does anybody have any other questions?
Steve, does the plasticity index in soils play any part in the calculation?
This is straight off a percentage of silt, and I presume that may influence your plasticity index, but it would be you'd have to run a hydrometer test to find out what your silt percentage would be, and that would be specifically the number inside it. So probably fairly indirectly it would.
I guess I have a question. So the plan here is you're gonna, right now it's, I guess for anybody to use, right? The MnDOT districts, the counties, the cities, and you're looking for feedback? Is that kind of?
Well, I've sent it out to the districts right now, and well, I haven't heard anything back from them yet because you only do so many of these kinds of projects. To say what to do with this, I guess, is kind of early at this time. If somebody said, is this what MnDOT is doing? The answer is no. And if it says it's calculating 13 inches or 40 inches, is that what we should do? And I don't know. If anybody wants to look at, they're welcome to have it and to give any comments to it. But we're very early in the stages, and what to say about it that as a implemented thing is, I'm not sure yet.
So, but I guess if anybody, right, if someone's curious and wants to run the software, they could send you an email and they could try it out, I guess. Right?
They could.
Okay, here we go. Any other thoughts? So I just want, you can see Steve is an implementer. He didn't talk for half an hour. In 10 minutes, he covered the ground and gave you a nice, very direct tool here. So I can thank you, Steve. Great example. So next up, we got Dave White. He'll be, and that's again the binders on desk. I guess Dave is going to refer to those binders. Dave, we've had a long partnership with Dave White, both